Briefly before we kick off, I also wanted to thank our sponsor, NetSpy. NetSpy is the global leader of offensive security. We offer a complete range of services, including pen testing, attack surface management, and breach attack simulation. Our cutting-edge tech and expert team help organizations identify, prioritize, and fix security vulnerabilities. Scan the QR code to be entered to win a JBL Clip 4 speaker. They will be in the sponsor room right there. Q&A after the talk. Break soon thereafter. Please welcome Chris Weber. Thanks.
All right. Good morning, everyone. So today we're going to talk about my adventures, or rather my misadventures, as I've run IT and product operations. So I'm not a security person by trade. I am the person that runs the actual infrastructure, but I've run into a number of security gotchas and things that are just worth knowing about, or at least a little funny as we've gone through the world. So, some of my remote works. So, before we talk, let's talk a little bit about what the world actually looks like for me. So, we are a DSPM platform, which means we do a lot of talking to your AWS environment to understand, or your GCP environment for that matter, to understand what your configurations look like, what data you have in that environment. And I'll get into some of the details about how that works and how that's played out in really interesting ways. We, like anyone that's built anything AWS based in modern times, we use lots of AWS accounts. We have an AWS organization where we really focus on, if it has a separate purpose, we build a separate AWS account for that thing, all of those sorts of things. What's interesting though is we are single tenant Kubernetes. So what that means for us is that every time we spin up a new customer environment, they get an entire dedicated Kubernetes cluster. And really, it's unique to the customer from the VPC down. We joke that the only shared infrastructure for any one of our customers happens to be the AWS account that it's running in. And if those were more disposable, I'd probably do that too. So we also support, as I mentioned, GCP and AWS, which leads to some fun things. So let's dive into the sewer. Just by show of hands, how many people would just say, yeah, encrypt all the things? That's a good idea, right? I can tell cloud security engineers are in the room because they're like, you've seen KMS. Because who here knows the pricing for KMS? I'm imagining most of us see where this is about to go. So this, for those of you that haven't seen this is Cloud Health, and this is the dashboard. And in this little print down here, that's April 2022, and that's the normal spend in our data science account. And this number over here is 60K. I really should have actually pulled the slide where it showed the breakdown by day, because 95% of that came from a weekend where some data science stuff went sideways. And that blue, that's KMS. Yes. I've been joking this last week, or the last couple days we've been here, that one of the things I'm going to talk about is my $40,000 KMS bill. Oops. It's really, I think, interesting how it happened, but I want to point something out before we move on to the next slide. Can anyone guess what that is? That's guard duty. So, of all of this spend, which is essentially a whole bunch of S3 access, only like a quarter of it is actually S3. The rest of it is all security tooling. So let's talk about what happened there. At the time, we're using Lambda to do some data science processing, and that Lambda was calling Athena. Athena was timing out, which was reinvoking the Lambda. You can run up to 10 Lambdas in parallel at a time. There's another bit of data here that's really useful to know. We hadn't quite learned yet that small Parquet files are your enemy. So as a result, Athena was blowing up. The Lambda function was being reinvoked. And for a weekend solid, we ran S3 in Athena as fast and as hard as we possibly could. It resulted in $40,000 worth of spend in just KMS. It really caused me to think through, because like, I'm the ops guy. I want to go make sure that I'm doing the right secure thing. And as I talk with security folks, it's always make sure it's encrypted, make sure those things are there. And it caused me to go back and say, okay, do we really need encryption here? Does this make sense in this context? In particular, when encryption is just so expensive. And yes, us novice data scientists, we are going to do stupid things. And that data scientist happened to be me that day. And the problem becomes that the cost really lies on the security team, because it was all security costs, right? We can talk about, okay, so you spent 10 grand, but at a small startup, you get to, okay, $40,000 and all we spent it on was decrypting files? That's a problem. There is no place like production. It gets really interesting here. So we use Lambda functions in your environment. So I don't want to run an agent in your environment to scan your data, but I also don't want your data touching my environment either, because that's bad for obvious reasons. So what we do is we inject a Lambda function into your environment. We then synchronously invoke it. So the cool part here is that it leaves open a TCP session and waits for the return, which means I don't have to have IP connectivity to get back off of your network, which is really cool, really scary. But you run into this problem where what we were seeing happen is we'd run that, we'd put the Lambda function there, we'd go through and we would then, it would just die. Like we would never get a response back, and we couldn't understand why. The detail that I've left out is that there's a NAT gateway involved here. So when we set up our original Kubernetes clusters, we put the nodes behind NAT gateways because good security, right? Come to find out, the NAT gateway actually has, oh, I forgot about the cool animation. Check this out. Because it really would. It was so funny because it worked 90% of the time, and then 10% of the time, it would just like fall off the face of the earth. Like, what happened? Well, after a few months and lots of talk with AWS, we were finally able to track down actually NAT gateways have a 7-minute TCP timeout. So if you're not sending TCP keep alives to keep that session open, it will fail. The problem is that if you're also running Kubernetes in a secure manner, setting up at the TCP stack level to send TCP keep alives is a pain in the butt. Long story short, we ended up ripping out the NAT gateways, mainly because as the ops person, I get charged for the costs of things, and NAT gateways are incredibly expensive. And we didn't realize just how much of our traffic, because we're in US West 2, but if we're scanning buckets in, whether it's US East 1 or US East 2, that bill adds up real fast. All right. So this is where things get really fun. And we're not going to just leave AWS out of it. So there's this really interesting thing as we went and built permissions. We're really big about not hurting customers. We want to make sure that when we hand you the permissions and stuff you need to set up in your environment, you can safely run that Terraform and not end up in a bad spot. So what I'll just basically say is, how many remember sharding databases back in the day? Like we would break them apart for performance purposes. Yeah, I had to shard my GCP roles to be able to get them to work with the level of permissions that we needed to appropriately do what we do. Yeah, I'm bothered that I even have to say that. Like the idea of sharding roles is just nuts. For those that don't know, because I know most of us have been talking AWS most of the week, a role in GCP is actually what we would call a policy. So think of really long policy documents. In AWS, the way we solve this is we just use the read-only role. And I know that there's lots to be said about that's very overly permissive. We're doing a lot of CSPME stuff. We can talk through as to why it just doesn't make sense not to use the read-only role. But in GCP, we wanted something similar because we never wanted to be in a place where a customer came back to us and said, hey, you found the data over here, but we need additional context about these other 5 objects so that we can actually make reasonable decisions around the data that's there. So we set out to go build we set out to find one, but come to find out, GCP doesn't have a built-in role like that. So cool. We found the viewer role, which gets you really, really close. But there's a problem. In GCP, everything is done via Terraform. There really isn't a CloudFormation alternative. So, and the bindings are done at the role level. So if OpenRaven comes in and asks for viewer at the organization level, and we instantiate that, guess what? Every other security principle that had that binding has now been blown away. Goodbye. We started looking at this, and it was just that moment of, oh God, if I hand someone Terraform and it blows away their IAM bindings, that's not going to look good, especially because you have to do that as part of the POC, right? Like, I haven't even gotten in the door yet. And it was just disheartening. So we're like, okay, cool. And what we've done internally to solve some of these problems is we'll copy that role over to the other role, and it'll have all the permissions, and it'll just be the special OR viewer role. Except that doesn't actually work. So GCP, when you go to do that, gives you an error that you can only have 3,000 permissions in a given role. If you have GCP access right now and you go pull up the viewer role, you will find that it has more than 3,000 permissions associated with it. Cool, all right. Get the list down to 3,000 and we'll create a role. Except that blows up too. So we ended up finding, and it was legitimate trial and error. Like I was sitting at, I think actually I was sitting at the LAX Marriott lounge, just sitting, pounding on the computer, like, how am I going to make this work? And what we ended up doing is just, we've got this huge list of roles, and then Terraform automatically creates and shards them out into the number of roles. We found that it's 1,750 was about the right number of permissions we can fit inside the role. And I postulate, I don't know for a fact, it has to do with the actual like body size of the JSON. So interesting adventures. The key is that we're going to continue to do these things. It's what we all run into. It's these little things. So my hope is that you've at least gotten a chance to see some of the fun plumbing and a taste of just some of the crazy things we run into as we're trying to actually do things in a secure manner. If you get a chance, I will be hanging out. We've got a table in the expo hall, and I'll be available for obviously questions here, but also questions at the booth. Thank you very much.
One question to start with. A lot of this talk really focused on the underlying AWS tools that you ran into problems with. Were there any sort of like software or open source tools, or like what else did you end up using in sort of building your platform? So we've really avoided wherever possible. We've avoided COTS for the most part. We use open source tools where appropriate. So like, for example, some of the data scanning engine actually uses Tika under the hood. But for us, it was really, and I live on the operations side, so it's all about the Kubernetes infrastructure. It's how do I actually limit access and do the things that I can go back to a customer and straight face say, this is how we built the infrastructure. And yes, your data, and
thank God, none of your actual data is safe with me.
And one other question. The $40,000 KMS bill is definitely, I think, I wouldn't say scary, but also very familiar to most of us. What have you built in to monitor and prevent against that, in the future, to focus your response when something starts to go awry?
So I enabled a bunch of additional billing monitors. We really took a big step back and talked about architecture, like thinking through, okay, as we look at new AWS services, we very much so include the bill as part of how we think about it. So one of the things we've talked about internally is we use Kafka heavily inside the Kubernetes cluster. For a couple of applications, it was like, okay, well, could we use SQS? And as soon as you look at SQS, you go, oh God, like the price is so high to do anywhere near the messaging I'm doing on top of Kafka that I'd be bankrupt just doing a single scan job.
Any other questions? All right, thank you so much. Cheers.